Hi, my name is Matteo, and I'm a senior software engineer at the Harvard Library Innovation Lab. Today, with my colleague Kristi Mukk, we're going to talk about WARC-GPT, an open source tool for exploring web archives using AI. So the Library Innovation Lab is part of the Harvard Law School Library, and part of our mission is to bring library principles to technological frontiers. Applied to web archiving, this led us to create PermaCC, which many of you already know, but also PermaTools, which is a series of open source web archiving tools. It's also under that framework that we approach this AI moment. And by AI moment, I mean the AI all the things phenomenon we observed since the launch of ChatGPT in late 2022. And this all may feel at the same time overwhelming. First, because there's so many models to choose from. On Hugging Face alone, which is a platform for sharing open source models, there's over half a million models available. And even if I just focus on the text generation models, so the models that behave a little bit like ChatGPT, so there are 60,000 models to choose from. So I don't know which one is the best, or even which one is the best for my specific use case. Keeping up with AI research is also very difficult because it's become the focus of so many research groups around the world. But at the same time, this is a little bit underwhelming, I would say, because veracity is a major concern. AI hallucinations, which is a misnomer to describe the fact that sometimes AI models make up stuff, has become its own field of research. We now use generative AI in mission-critical scenarios, and that makes it all the more important to figure that out. And if veracity is a major concern, so is accuracy. Impressive AI output doesn't always stand the test of scrutiny, as you may be able to see in the example that I generated and pasted here. It's subtle. But overall, this moment feels, I would say, disempowering. We are being told that AI will change everything and its opposites. It's going to create all the jobs and destroy all the jobs. That it's going to create an economic boom and economic collapse. But rarely are we told that we have a role to play in shaping what AI can and will do for us. We are constantly exposed to a serial imagery of superhuman intelligence that shows AI as sort of an unstoppable force. Most news articles I read about AI feature an illustration that looks just like this, and I don't think it helped me feel empowered to experiment with AI. It doesn't look like a toy, it looks like a Terminator. So what we're trying to do is to take a step back and wonder, what can we do with AI now, and why does it matter for knowledge institutions? And we think that, in part, this boils down to, if I can ask a question to ChatGPT instead of Google or my librarian, then large language models are a new way of knowing. AI models accidentally know things. They were trained on vast amount of data, retain some of that information, and are able to restitute an even smaller subset of that. At the same time, they also show promising capabilities in summarization and sense-making. And I wonder if we can use that to help improve access to knowledge and understand collections more deeply. Furthermore, as a lab, we wonder how we can lower the barrier entry for experimentation with AI technologies. So these questions allow us to explore different flavors of RAG, which is the acronym for Retrieval Augmented Generation. So RAG is a series of techniques that allows for connecting a large language model to a knowledge base. That knowledge base can be anything. It can be a database, an API, a series of documents, or even a single document. The way these two elements are connected together is through a prompt, which is a series of textual instructions that tell the model what type of response to generate. In RAG, the focus is on that prompt that is used as a way to pass structured information to the model in order to elicit more grounded or factual responses. You can also use RAG as a way to take advantage of the sense-making and summarization properties of large language models I was just mentioning. This is something we've explored with WARC-GPT that I'm going to talk about a bit more now. Okay, so that was a long intro. WARC-GPT. So it's an open source RAG pipeline for exploring web archives. The question we asked ourselves here was whether we could use RAG as a way to help extract hard to find information out of web archives collection. We also wondered if we could do that in a way that could help the web archiving community engage with these questions. So we've built and released an open source chatbot that you can download and run on your machine. The main feature of WARC-GPT is that it lets you ingest a web archives collection and ask a large language model of your choosing questions against that web archives collection. There is a focus on interpretability, and WARC-GPT will tell you exactly what part of the web archive collection it used to help the model answer your question. There is also a focus on configurability, and every single part of a pipeline can be inspected, edited, or replaced. we don't think of WARC-GPT as a production-ready chatbot, but more as an experimental boilerplate, something you can use on your machine to explore the interaction between AI and web archives. In that spirit, WARC-GPT can talk to both proprietary models like OpenAI's GPT and so on, but also open source models. It's also possible to switch between models as the conversation goes, which yields interesting results. Finally, WARC-GPT comes with a REST API, so you can build on top of WARC-GPT. Not every experiment fits into the context of a chatbot, so we figured it was important to provide another way of interacting with that pipeline. So the RAG flavor we use here is what I would call vanilla, in the sense that it's the most common way of implementing retrieval augmented generation. But I guess a more technical term for it would be vector-based asymmetric semantic search. So let's break that down a little bit. So the knowledge base WARC-GPT uses comes from text it parsed out of WAC files the user provided. The text excerpts are extracted from HTML and PDF records, and they are processed by a text similarity model. That's the important part. And once they are processed by the text similarity model, they are stored into a vector store, which is a specialized type of database. What a text similarity model does is that it encodes the meaning of a text excerpt into a vector, which is a series of numbers. When you do that at scale, like for an entire collection, that lets you perform search by grouping vectors mathematically, for example, using cosine similarity. Since the vector represents the meaning of the text excerpt, and it's all math, you can, with math, group vectors by their meaning. The asymmetric part here is that the questions and the text excerpts we ingested are very different in their shape. And for example, one is a question that's very short, and the other is like a text excerpt from a WARC. So the text similarity model is trained to group these vectors by their meaning, even if it's like one is a question and the other is like a description, for example. That's the asymmetric part. So that's a lot of words. And I figured I would show a plot, and maybe it's not clearer, but I'll try. So this is a very simplified 2D plot, TSNE plot, of a vector stores that WARC-GPT generates. What you see here is that the blue dots are text excerpts that were ingested by WARC-GPT, and the red dots are questions that we asked. The way this works is that WARC-GPT will use the blue dots that are the closest to the red dots to help answer questions. So that's a very simplified explanation of how vector search works and how WARC-GPT performs search. By the way, WARC-GPT comes with a feature that lets you generate charts just like this one, so you can see how well it ingested your collection. And you can also replace every single part of a RAG pipeline I just described through the configuration file.
So we put WARC-GPT to the test with a small experiment to see if it would behave as designed. And we were particularly interested in seeing how WARC-GPT might be able to highlight the utility and value of web archives by allowing users to access them in a new way and offering a different starting point for scholarly inquiry. So how might WARC-GPT help reveal connections that may have been hidden or hard to find, or help you find relevant resources more quickly? And so we put together a small thematic collection of 78 URLs about the lunar landing missions of India and Russia in 2023. And we chose this topic because these models were likely unaware of recent developments in these missions as they were trained and released before these lunar missions were launched and completed. And so for our experiment, we used WARC-GPT's default configuration and used Mistral 7B as the model at temperature 0.0, and we had 10 questions in a 0-shot prompting scenario, and we did with and without RAG for comparison. And as Matteo and I collaborated on this experiment, we found that with our unique perspectives as an engineer and myself as a librarian, we really had that collaborative problem solving that working with AI really requires. And I think librarians should be collaborating with engineers in the building, management, and evaluation of these kinds of tools. And so some of the things that librarians can help with is navigating the overwhelming amount of AI resources and tools that are out there, helping to identify a suitable collection as a knowledge base for AI applications or vetting AI data sets. With their knowledge of user needs, librarians can also identify specific problems or use cases that AI is well suited to address and when alternative solutions might be more appropriate. Problem formulation, so thinking about what are some of the questions a user might want to ask about a collection, going through the prompt engineering process of creating and refining prompts and knowing what context to provide to the model, and also critical evaluation, which I'll talk a little bit more about later. And a question at the forefront of our minds throughout this experiment was how might we leverage tools like WARC-GPT, not only for accessing web archives, but also as a tool for AI literacy, because AI literacy is part of information literacy. So thinking about how this can start a larger conversation about reaffirming library principles as users explore these different tools. So thinking through questions with users like, how did this AI tool arrive at its search results? And how can we help users go from thinking about generative AI as merely a tool to thinking about AI as a subject worthy of investigation in and of itself? And more broadly, thinking about how AI might change how we communicate, learn, and make sense of the world. And this new mode of access comes with some important trade-offs in comparison to traditional search. It's important to remember that variability is not a bug, but a feature of large language models. And LLMs really sit at this interesting intersection, being neither a database that we can query facts from, nor a person that we can ask to perform judgments. And we see them instead as imperfect simulations of what a person could answer to a question, providing statistically reasonable responses to prompts. And so understanding the underlying limitations and potential is really key for AI literacy and trust calibration, because users may place too much trust in AI without critically evaluating its output. So for our particular experiment, we analyzed the output and were inspired by this paper by Janap et al. That outlined these different criteria. So we analyzed the responses one by one and looked at factors such as coherence. So how is the response structured in terms of its logic and style? The coverage, so how pertinent was the response to the question's information need in terms of the breadth and depth? And were the text excerpts that it pulled relevant? Looking at the consistency, whether the response was free of any contradictions, did it accurately reflect the source information and context the system was provided, and did it use that context appropriately in its response? We checked for factual errors, and we also looked at the clarity in terms of the language and content. So let's take a look at one of the embeddings from the experiment. So this is one of the embeddings retrieved in response to the question, identify the cause of Luna 25's crash. So the text in red are the words that were used in the prompt itself. So you'll see Luna 25 crash and cause in red. And then the highlighted yellow text is the portions of the text excerpt that the model pulled into its response, which I'll show on the next slide. And you'll also notice that there is a bit of noise in the first part of this excerpt, which the model did manage to ignore in its response, which is here. And you'll see that it is quoting near verbatim from a lot of that text excerpt in its response as well. And so as all of you in the audience experiment with AI or are interested in experimenting with AI, we really encourage you not only to talk to a librarian, but also to think like a librarian yourself. I think AI experimentation should follow this continued cycle of reflect, refine, and repeat. And metacognition really plays a crucial role in AI literacy, because in order to effectively calibrate your trust, you have to be able to form a correct mental model of where AI's error boundaries are, and also engage in critical reflection throughout that process. And so we've coined the term librarianship of AI to describe this emerging practice and guiding framework as we build tools like WARC-GPT to lower the barrier of entry for web archivists, librarians, and others to understand AI in their particular domain, and also empower them to form their own opinions and frameworks for thinking about AI and new ways to access knowledge for their communities. So we define librarianship of AI as the study of models, their implementation, usage, and behavior as a way of helping users make informed decisions and empowering them to use AI responsibly. So what's next for WARC-GPT? While it's still an experimental tool, we really hope that this is a step toward all of us collectively understanding the potential and limitations of using AI to explore web archives, and getting at this core question of how we can encourage users to explore the troves of information that are stored in web archives. And so we welcome any feedback and contributions from you all. The code is open source, so we do encourage you all to build on top of it and use it yourself. And we have some ideas about topics that we see as compelling looking forward. So we're interested to hear what sparks people's interest, but it would be great to understand some of the potential and limitations more deeply, whether that's testing the setup against larger thematic collections, doing some automated benchmarking to figure out how much a given model, how much a model knows about a given collection, thinking about description work and what that might mean for your team's workflow. Also, we could envision a future pipeline that has multimodal embeddings, so that would enable you to explore the images in a collection. Thinking about temporal search and understanding how a given website has changed over time. Thinking about web archive playback, that would allow for easier source verification and fact-checking and enable you to see the text excerpt in its original context. And then also adapting to new capabilities that may come with the rapid pace of AI development, because some of the challenges that we currently encounter today with RAG, such as context window length, that could be improved in the future. So if you want to learn more, you can see our source code and our case study on GitHub. And if you're interested in any of the other AI projects that we have going on at the lab, you can visit our website or contact us. And thank you. We look forward to hearing your questions and ideas.